In probability questions, whenever you see or use the word and, you need to multiply. If you see or use the word or, you need to add. An example of an and question would be this: a dice is rolled and a coin is flipped. What's the probability of getting a 2 on the dice and a head on the coin? Well, the probability of getting a 2 on the dice is 1 out of 6. And means times. The probability of getting a head on the coin is 1 out of 2. So to calculate the probability, I do this multiplication. 1 times 1 is 1, 6 times 2 is 12. So this is the answer for this question. An example of an or question would be this: a dice is rolled. What's the probability of getting a 2 or a 4? So the probability of getting a 2 on a dice is 1 out of 6. Or, that's plus, the probability of getting a 4 is 1 out of 6. So I need to do this to get the answer. So 1/6 plus 1/6 is 2/6, and this is the final probability. Remember, when you're dealing with probability, you don't need to cancel down your fractions. Now this is a hidden and question. Let's see why. I'm told that Dan and Chris play each other at tennis and chess. The probability that Dan wins tennis is 0.7, and the probability that he wins at chess is 0.4. I want to work out the probability that he wins both games. So that means he's got to win tennis and he's got to win chess. So the probability of him winning at tennis is 0.7, and the probability of him winning at chess is 0.4. So to calculate the probability, I do this multiplication. I get 0.28. I've changed the question slightly now, and it makes it much more complicated. I've got to work out the probability that Dan wins exactly one game. So that means he wins at tennis and loses chess, or he loses tennis and wins at chess. So the probability that he wins at tennis is 0.7, and the probability that he loses chess is 0.6 because the probability that he wins is 0.4. Or the probability that he loses tennis is 0.3, and the probability that he wins chess is 0.4. Now we need to remember to apply BODMAS, so we do the two multiplications first. So 0.7 times 0.6 is 0.42, or 0.3 times 0.4 is 0.12, and I add these together to get the final answer. That's 0.54. Here's one for you to try now. Press pause and have a go at it. When you're ready, press play. We want the probability that Dan loses both games. The probability that he loses tennis is going to be 1 minus 0.7, so that's 0.3. And the probability that he loses chess will be 1 minus 0.4, so that's 0.6. We multiply these together. 0.3 multiplied by 0.6 is 0.18. Here's another question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. Press pause and have a go. When you're ready, press play. We want to calculate the probability that the two spinners will land on the same colour. Now the one spinner has got red, green and blue, and the other has red, yellow and blue. So we can either have red and red or blue and blue. We don't need to worry about the green and yellow sides. So the probability of the first spinner landing on red is 3 out of 6, and the second spinner landing on red is 4 out of 6. For the blues, the first spinner is 2 out of 6, and the second spinner is 1 out of 6. We then apply BODMAS to get this, and add to get the final answer. Here's your final question to try. See if you can think of a quick way of doing this one. Press pause and have a go. When you're ready, press play. So here's the slow way of getting the answer. You've got to work out the probability of getting a toffee and a mint, or a toffee and a fruit, or a mint and a toffee, or a mint and a fruit, or a fruit and a toffee, or a fruit and a mint. And once you've worked all of that out, you need to add them all together and you get this answer. Now, I told you to see if you could find a faster way of doing this. This is the faster method. We work out the probability of getting the same type of sweet each time. So that's a toffee and a toffee, or a mint and a mint, or a fruit and a fruit. And once we've got that probability, we take it away from 1. So we get 1 minus 61 over 180, which gives us 119 over 180, the same answer that we had doing it the long way round.